We're going to split chapter 6, part 4 into two pieces. We're going to look at multiplying polynomials first. Next time we're together, we'll go ahead and divide polynomials. But just like when we added and subtracted polynomials, we're going to find out that your third grade teacher did all the heavy lifting for you. Pretty much already taught you the procedures that you need to know to be able to multiply polynomials. We're going to follow the same set of procedures that you use to multiply, say, for instance, a 3-digit number times a 2-digit number. And we can do this vertically. We can also do it horizontally. As an example, let's take a look at this product. X squared plus 4x minus 7 multiplied by x minus 2. If we take a look at those two things, if this was 147 times 12, you'd know what to do with that, right? We'd begin with the ones place of the 2, multiply times the 7. It's 14, we'd go ahead and carry. 2 times 4, which remember isn't 4, it's 4 groups of 10. So that's 80 and one more is 90. So 4 times 2 is 8 plus 1 is 9. And then 2 times 1 is the 2. We'd come back through with the 1, which is the tens place. Remember, this is 10 times 7. So that's 70. So we place it under the nines, the 9, which was the tens digit above us. Some of my students learned to place a 0 in that ones place column to hold that place. 1 times 4 gives us 4, and 1 times 1, and then add the place value columns going down. Multiplying polynomials vertically is pretty much as simple, and the added bonus is that we don't have to carry. So negative 2 times negative 7 gives positive 14. Negative 2 times 4x, negative 8x, negative 2 times x squared, negative 2x squared. Then we return x times negative 7, negative 7x. We don't even have to remind ourselves to put a 0 here in the constants column because we can see we have a negative 7x. We're going to keep our like terms stacked up together. X times 4x is 4 x squared, and x times x squared is going to give x to the third. Now we can add our columns going down. So x to the third plus 2x minus 15x minus 14. It turns out that we could multiply polynomials horizontally as well, and we're going to follow that pattern that we learned when we found out how to multiply two binomials together. We're just doing the distributive property repeatedly. So 3x plus 4 times 5x squared plus 6, plus x minus 6. Start with my 3x times 5x. That's 15 x squared. 3x times x. Really easy to lose an exponent here. So 5x squared times 3x is 15x to the third. 3x times x is 3x squared. 3x times negative 6, negative 18x. Now we come back. 4 times 5x squared is 20x squared. 4 times x plus 4x. 4 times negative 6, negative 24. Now let's combine some like terms. I've got a 15x to the third, positive 3x squared, and positive 20x squared. That's positive 23x squared, minus 18x plus 4x, so minus 14x, and minus 24. So we had a binomial times a trinomial. 2 terms times 3 terms. 2 times 3 gives 6. I had 6 terms in my partial products. 1, 2, 3, 4, 5, 6, and then combine the like terms on those. What happens if we have more than 2 binomials to multiply together? We're just going to go ahead and group up the first 2. Multiply those, take that product times the last one. So x minus 2 times x minus 1. X squared, negative 1x, minus 2x, minus 2. So I have x squared minus 3x minus 2. Now we'll multiply times the third binomial, x plus 3. X to the third plus 3x squared minus 3x squared minus 9x minus 2x See, that was a negative 1, so that's plus 2, plus 2. That's a plus 2x. And then plus 6. So here, positive 3x squared, negative 3x squared, those are opposites. They'll sum to 0. X to the third minus 7x plus 6. You'll recall from multiplying binomials that we had some special pairs of binomials that resulted in particular patterns. The sum and difference, a plus b, a minus b, resulted in the difference of two squares, a squared minus b squared. So x plus 4 times x minus 4 gave us x squared minus 16, which is 4 squared. When we squared a binomial, first and last terms were perfect squares. That middle term was 2 times each of the terms in the binomial. So for instance, x plus 3 squared gave x squared plus 6x plus 9. We'll move on forward a little bit. What happens when we want to multiply a binomial times itself 3 times? It's called cubing a binomial. Famous mathematician and philosopher Blaise Pascal came up with a number pattern, and he actually stumbled across this at about the same time that some other thinkers in different cultures around the world, and actually somebody actually come up with this earlier, had also come across this same pattern, but it was named after Pascal, called Pascal's triangle. And as you went on down, ones in the first and last places on each line, each row, but then beyond that, adding the two numbers above it to fill in that row. So 1 and then 1 plus 2 is 3, 3 and 1, 1, 4, 6, 4 and 1, which is, kind of a fun little pattern, but it turns out that it's embedded into a lot of really neat math, including this kind of what's called binomial expansion. So when I multiply this out times 3, I'm going to go to row 3, 0, 1, 2, 3 of Pascal's triangle, and those are going to end up being the coefficients of each of my terms. So there's a pattern for cubing a binomial, whether it's a plus b or a minus b, which is listed here on the notebook page. So we look at 4x minus 1 to the third power. And if you forgot the pattern, weren't comfortable with it, you could certainly go ahead and multiply this by itself 3 times, and that would be fine. If we were expanding this out to the 5th or the 10th, you wouldn't want to do that, though. So we know that a minus b is going to equal a cubed minus 3a squared b plus 3ab squared minus b cubed. So how does that work with this one? One of the things that you'll notice, here's 1, 3, 3, and 1 are coefficients, just as in Pascal's triangle. And if you take a look at the exponents, the a exponent goes 3 to 2 to 1 to 0. The b exponent goes from 0 to 1 to 2 to 3. So if we can follow this pattern, we're in pretty good shape. So 4x, take that thing and cube it. 64 x to the third power. I'm going to have minus 3a squared b. So a squared, 16x squared times 3 is 48x squared times b, right, which is 1. So minus 48x squared. Plus 3 times a times b. 3 times a is 12x times b is 1. And then negative 1 cubed. So that's the result of cubing 4x minus 1. And again, you could go ahead and multiply that out, 1 times 1 times 1, and come up with the same answer. All right, so we take a look at a couple of word problems. It's geometry related, and we're given a couple of rectangular prisms with some dimensions given as algebra expressions, x plus 5, x plus 3, x plus 1, and we're asked to find the volume. Well, volume is length times width times height. So let's go ahead and take these one pair of binomials at a time and then times the third. X squared plus 3x plus 5x plus 15, so x squared plus 8x plus 15, and we'll multiply that times x plus 1. x to the third, plus x squared, and then plus 8x squared, plus 8x, plus 15x, plus 15. Combining our like terms, x cubed plus 9x squared plus 23x plus 15 cubic units. So all these problems are is an exercise in multiplying three binomials together. X plus 1, x plus 2, x minus 1. Let's repeat. X times x squared, plus 2x, plus x, plus 2. So x squared plus 3x plus 2. And we're going to multiply that times x minus 1. X cubed minus x squared plus 3x squared minus 3x plus 2x minus 2. Combining like terms now, positive 3x, negative x, 2x squared minus x minus 2 in units cubed.